Okay, this is web assign 5, number 18. And the question read, a 3.1 kilogram steel ball strikes a wall with a speed of 11 meters per second at an angle of 60 degrees with the surface. It bounces off the wall with the same speed and angle. If the ball is in contact with the wall for 0.2 seconds, what is the average force exerted by the wall on the ball? So, okay. So first, let's draw a picture of this. So here's the wall. This is the path it takes. 60 degrees. 60 degrees. Excuse me. And then we'll call up and to the right positive. And we know that it is going at a speed of 11 meters per second, and it weighs 3.1 kilograms. And we know the time is 0.2 seconds. Oh, excuse me. Okay. So the average force exerted on the wall by the ball. So we are going to do force is equal to the change in momentum over the change in time. So we basically are going to find the force in the x direction and then the force in the y direction. So to do that, we will do, so for the momentum, it's 3.1 times negative 11 sine 60. And it's negative because the final, so when you do change in momentum, you do final minus initial. And its final will be going in a negative direction because we call the right positive and it will be going to the left. So that is why it will be negative minus 3.1 minus the initial, which is 11 sine of 60, positive because it's going to the right initially. And then all of that will be over 0.2 seconds. Okay. And that final force gives you the force in the x direction, gives you negative 295.3. And that makes sense because it will be going in the negative direction. And then now we have to find the force in the y direction. So we would use the same equation, F single change in P or a change in T. So that would be 3.1 kilograms times 11 cosine of 60 minus 11 cosine of 60 and over 0.2 seconds. And what we see is that the final minus initial would be 0. So therefore the final force in the y direction would be 0. And this makes sense since it's like it makes sense that it's a 0 because there's no like change like in the y direction, so it just stays constant. Like there's only a change in the x, so that's why it'd be 0. So that's what some people don't get is they mess up with the finding the y direction, or they mess up with the trig and they don't know that you have to go. So since this is the resultant force, and this is 60 degrees sine theta, and then 11 cosine theta. Sometimes you mess up with the trig. So basically, just be careful when you're doing the final minus initial and watch your direction. Watch in case it's negative or positive. And yeah. So what I learned from doing this problem is that sometimes there won't be like a change in like the force in one direction, but there'll be a change in the other, or or some, yeah, and then so basically one of them will have a change and the other one might not. I'm pretty sure they both could change. But yeah, it's a pretty basic problem.